We're going to graph the line y equals 1/2 x minus 3, and we're going to use slope-intercept form. We're going to start with the -3. The -3 is our y-intercept. On the y-axis, we're going to go down. We're going to plot a point at -3. From that point, I'm going to travel to another point on the line using my slope. So from this point, I'm going to go up 1 and then 2 to the right. Since it's positive, I travel upwards. Had it been negative, I'd travel downwards. And if you always let the positive or the negative tag along with the up or down idea, then you will always travel to the right from there. Now, depending on how you guys have done these in the past, right, 2 points determine a line, so basically I got enough information right here to draw the line. You could also keep going up 1 over 2, up 1 over 2 to get more points. But as far as I'm concerned, 2 points determine a line. Once you get those 2 points to draw your line, I'm feeling frisky here. I'm going to freehand this. I encourage you to use your ID or a straight edge. That's not a bad start. If you look at B now, following the same procedure, y equals mx plus b, using slope-intercept form to graph, I start with y-intercept of +5. So on the y-axis, I go up to 5. I plot a point. Taking the coefficient on that x, which represents my slope, got -3, so it's understood to be -3 over 1. From the y-intercept point, since that's a -3, I travel down 1, 2, 3, and then 1 to the right. Got my 2 points, draw my line. On C, we've got y equals -2/3 x. As I mentioned before, when we're talking about slope, if it's a negative value, let's go ahead and let that negative value be associated with the numerator. That way we understand we're just traveling downwards to start and then always to the right. We don't see a b sitting there, so it's understood that +0 could be tacked on, making our y-intercept 0. So I plot a point on the y-axis at 0, and then from that point I travel down 2, since it's negative, and 3 to the right. So there's a general application of slope-intercept form, assuming that y is already by itself, right? These first 3 are set up pretty nice. We get down to part D. On part D, we see that y is not by itself, so what we do is we first solve for y. We put it in the slope-intercept form and graph from there. So solving for my y term, I would subtract 3x over. Being consistent with my slope-intercept form, as I write this out, what 2y should equal, it should equal -3x plus 8, right? Because I want it to be mx plus b. If I divide everything by 2 now to get y by itself, dividing 2 to each term over here, I've got -3 divided by 2, so -3/2 x, plus, I've got 8 divided by 2, 4. There's my slope-intercept form. On the y-axis, I travel up to 4, plot a point. Got -3/2, so from that point, I go down 3 and 2 to the right. Yeah, I know I got a line tool. I don't have to do that straight hand, but I'm really good at it. What, no applause? All right, fine. Moving on to the next page. More examples. Let's look at number 5 here. It's lined up a little better. Same scenario as the last one. You got to solve for y first. So get that y term by itself, subtract 3x over. Try to get everything lined up here so that you've got that mx plus b idea. So x term first, constant term second. Watching your signs carefully on this one, you got the negative y you're bringing down, so we divide everything by -1. If I divide everything by -1, I'm just changing sign, so it becomes 3x plus 5. Y-intercept on this one being 5. Plot my point at 5. From that point, I go up 3 and 1 to the right. That was an okay effort. All right, we get down to F. F is kind of unique. I want to be real specific here to that slope-intercept form. I could say y equals, since the x term is missing, I could say 0x plus 7, right? Now, if I were to graph off that form, the y-intercept be 7, so I'd go up 1, 2, 3, 4, 5, 6, 7, plot a point. Since the coefficient on x is 0, I could make that 0 over 1, which would mean from this point, I would not travel up or down any spaces, and then I'd go 1 to the right, which means when I plot my next point, the kind of line I get back is a horizontal line. So normally when we do these problems, where it's y equals just some value, we don't use slope-intercept form. We just recognize that this is a special line. And we say that, all right, if it's y equals just a number, that's going to be a horizontal line. And appreciating on that example that you've got a horizontal line to work with, when you look at G now, on G there's no y to solve for. So we'll just take the variable we're working with here, which is x, solve for x. Divide 2 over, x is going to equal -3/2. If y equals just a number as a horizontal line, then x equals just a number must also be special. In fact, this is going to be a vertical line. So on the x-axis, where x is -3/2, that'd be -1.5, right? You're going to go to that point on the x-axis, which is approximately right here, and draw yourself a vertical line through that point. The point on the x-axis we go to would be this value right here, -3/2, so it'd be -1 1/2. Dividing it out to that mixed number would probably make more sense if we're going to graph this. All right, so as we get to our last few examples here, it gets a little more challenging. You'll notice on part H, we need to solve for y, but we also have those ever-popular fractions. So what I would do is I would take into consideration these denominators, find the least common denominator between those two, which would be 12, multiply both sides by 12. That will allow me to clear those fractions out. So when I take 12 and I distribute through to this first fraction of 1/3, 3 goes into 12 4 times, so it'd be 4x that's left, minus, take 12, distribute to this 1/4, 4 goes into 12 3 times, so it'd be 3y left, equals 12 times 2, 24. Now let's solve for y. To solve for y, isolating the y term here, subtract 4x over. -3y is left. That is equal to, rearranging my terms, -4x plus 24. Now go through and divide everything by -3. When I do that, I've got -4 divided by -3, so that's +4/3 x. And I've got 24 divided by -3, which is -8. Got your slope-intercept form. So on the y-axis, I go down to -8, plot my point. From that point, travel up 4, 1, 2, 3, 4, and 3, 1, 2, 3 to the right. Draw your line. All right, last page, next couple of examples. Okay, we have a form here on I that I'm going to discuss a little bit further here in just a moment. It's actually a particular type of linear equation that's given. But for our purposes here, which right now the initial goal is to put it in slope-intercept form, let's solve for y again. Solving for y, I would take this -3, right, add it over. I'd have y equals, I know I need to distribute that 2/5, so if I distribute that 2/5, I get 2/5 x minus 2/5 times 1, 2/5, plus 3. At this point, I got to combine like terms. So y is going to equal 2/5 x, but I can take that -2/5 and add that 3. A couple ways to do it. Find a common denominator. If you find a common denominator, this would be over 5, meaning I got to multiply the top by 5, right? So this would be 15 over 5. Take -2 plus 15, that's going to be plus 13/5. Another way you could do this, and it'll make more sense when we graph it here in a moment why you might do this. If you take 3 and subtract 2/5 from that, you'd have 2 and 3/5, right? You'd have that mixed number that would be easier to graph. So take 13 divided by 5, what do we get? Well, we get 2 and 3/5, same thing. As you plot that y-intercept point, 13 divided by 5 being 2 and 3/5. I'm going to go up on the y-axis. There's 2. Somewhere between 2 and 3 is going to be 2 and 3/5. I plot a point. I respect the fact that now I'm not working exactly at 2 or 3. So as I count up, I'm going to have to kind of hover in between lines, right? So from that point, I'm going to go up, according to my slope, 2. So 1, 2. And then to the right, 5. 1, 2, 3, 4, 5. Got your 2 points. Draw your line. Oh, that one got away from me. I'm sorry. Oh, that's no good. My streak is over. Sorry. Use a straight edge, right? Last one. As we look at the last one here, we recognize we have a proportion that we're working with, right? So if you have a proportion, cross multiply. Take 3 times that quantity of x minus 5. That's going to be equal to product for the other diagonal, which would be 2 times quantity y minus 3. Do some distributing. You got 3x minus 15 equals 2y minus 6. Remember, you're solving for y here, so add 6 over. It'd be 3x. All right, minus 15 plus 6. Minus 9 equals 2y. Divide everything by 2. I'll switch this around a little bit. So divide everything by 2. Be y equals 3 divided by 2, x, minus 9 divided by 2. Got a fraction to deal with again for the y-intercept. But understand you're just taking 9 dividing by 2 to give you 4 with a remainder of 1, right? So it'd be 4 and 1/2. I go up, or rather on this one I go down, right? 1, 2, 3, 4, and 1/2, plot a point. And then from that point, go up 1, 2, 3, and 2, 1, 2 to the right. All right, let's finish strong here. Ah, there we go. Snuck it through there. Not bad. There's a little review of graphing lines using slope-intercept form.